Uh, Thanks everyone for joining my talk. Thanks a lot, Bogdan, for the great talk and for the clicker. And let's talk about making something easy, which is logging Apache Spark. So what are we going to talk about in the next 20 minutes or so? So we're going to start about going an overview about Nielsen's data architecture. We'll talk about how we used to access Spark logs, how we used to log it. We'll do a deep technical dive into the solution overview, the solution that we've devised to actually making logging Apache Spark easy. Some main obstacles, because every solution has to have an obstacle, some pretty Kibana charts, and to top it all up, some future add-ons. But first, the most important thing, who am I? So who am I? I'm Simona, I'm 29 years old. I've been dealing with data for 10 years now, which feels like a lot. I'm joining you here from Israel. I'm a big data engineer at ADOC, but I did work at Nielsen or up to a few months ago, so this is totally based on a true story. I love music, the weirder the better. I love traveling, and I love Japan. So basically, this is me in a picture. So I think the first thing that really pops out when you look at this data architecture is Spark. Spark is responsible for more than 50 terabytes of the events flowing into this architecture daily, billions of events, and Spark is doing everything. It's deserializing, enriching, aggregating, and then eventually storing all of that data in all of these different data stores, each serving a different purpose and a different application. And so I think a big part of your job as a big data engineer at Nielsen Israel would be just developing and maintaining these big Apache Spark jobs and streaming applications. And I think it's really important to notice at this point that we were running Spark on what was, or probably still is, the most popular platform to run Spark on, which is Amazon EMR. Now, if you're not familiar with Amazon EMR, EMR stands for Elastic MapReduce, and it's a cluster, right? It's a cluster with some predefined software installed in it. And in Amazon terms, it's just a bunch of EC2 servers running together. So I think before we start our discussion about how we used to access logs, we really need to talk about when we access logs. And we access logs in one of two cases, right? So the first one be when you've just developed a new Spark application, you launch it on your EMR, and you just want to follow it up. So you want to access your logs. And then the second would be when you have a production issue. And you might know that the problem is with Spark, or you might not. But essentially, you want to access the logs. And in both of these cases, time is an essence. So now let's talk about how we actually used to access Spark logs. So the first way is the most direct way. You can SSH straight into the EC2 server, right? And the thing with that is that Spark has several components, right? We have the driver, we have the executors, and each one of them is outputting logs. So you have to first find the right EC2 server to SSH into, the EC2 server running the component. Then you have to find the relevant log file, decompress it, start searching it, and then just hope that you found the right log file and that you found what you're looking for. And we do have a centralized way of accessing our logs, right? You can always pick up your favorite web browser and go to the Yarn UI. But the thing with that is if we think again about when we access logs, our application was already probably running for quite some time now in most of the cases. And so we already have quite a lot of logs. So what would happen is that your favorite web browser would probably just crash and die. And so at this point, you'll go to the last but not least way of accessing your logs when running Spark on EMR, and that would be just accessing them straight on S3. So Amazon do provide us with that possibility, right? They do migrate all the logs from all the EC2 servers and into S3. But the thing is that with that is that there's quite a time gap, right? So it takes about 5 or 10 minutes. And when we think about when we want to access our logs, when we think about the time is an essence, that is quite a waste of time. And for that reason, we've designed and developed a solution that would just make accessing Spark logs, searching them, visualizing them easy. And that's why we just base this entire solution, base this entire architecture on the ELK stack. with Beats being the real star, the core of this architecture. Now, if you're not familiar with Beats, Beats are open source, lightweight shippers, each one dedicated to a different type of data. And for this architecture, we are going to use two types of beats. So the first beat that we're going to use is file beat. That's for the log data. And then the second beat that we're going to use is metric beat. Because if we're already there, why not collect all of these metrics off of our EC2 servers? So what are we going to do? We're going to install our beats on all of the EC2 servers using some Bootstrap actions, and we'll just deep dive into these Bootstrap actions in just a minute. From there, we're going to ship all of that data into Redis. We'll have some Logstash servers consuming all of the data off of Redis, indexing it in Elasticsearch, and then, of course, you have Kibana for search. So let's start talking about those Bootstrap actions. So what you see before you is just taken off of Amazon's documentation. We're going to use Bootstrap actions, what they're meant to do. We're going to install additional software on our EC2 servers. And I have for you today a snippet off of our own Bootstrap actions. If you look at number 2 and number 3, you can see that we're going to install metric beat and file beat. And we have a bash script that's going to do it for us with quite a lot of configuration variables. So don't worry, we're going to understand all of these. So now let's really go into that bash script, because I think that's the most interesting thing in this architecture, and the most difficult one. So what's the first thing that we need to do when we install FileBeat on our EMR? The first thing that we need to do is just make sure that we're not running on the master node. Why is that? Well, simply because Spark is not running on the master node, so we don't want to install FileBeat on that node. Luckily for us, Amazon do provide us with that information. It resides in the instance JSON file, so the moment we get that information, we can decide if it's the master node or not, and then just go on. The second thing we're going to do is, we're going to receive those configuration variables. So we're going to have two types of configuration variables. We're going to have, I'm going to call them the first part for the future, and then the second part for the legacy. So what are for the future configuration variables? These are variables that are going to enrich our logs and are going to make just searching logs in the future easy. So anything you can tag your logs with. Does this clicker have a laser light? No, it doesn't. But, okay. No. That's fine. So what kind of information is that? Things like team name or flow name, anything that is going to make searching these logs easy. The second type, for the legacy, to understand what type of configuration variables are these, we need to understand Nielsen's data group. So I think that Nielsen's data group at Israel went through what a lot of data groups go through. So we started from 1 data team, and we grew to 3. And as it happens, usually, each one of these data teams had a different log4j file and different Spark applications. And so at this point, we said, you know what? That's fine. You don't have to change your log4j file. We'll just make this installation, this FileBeat installation, custom per team. You just can configure it the way that you want. So what type of configuration variable that would be? Things like regular expression, right? What does our log start with? How does it look like? What's the log file name? All of these configuration variables are just going to make FileBeat custom made, tailored for that team, using it for that specific EMR. The next thing that we're going to do is just make sure that HDFS and JDK are present on the server. Why? A, it's a prerequisite for installing Beats, and B, we're going to look for files in the HDFS. So we can't really install and start our FileBeat before HDFS is present on the server. So this is what I did. It's just a while loop, right? But it works. If you want to implement it any other way, you can. So now that we've got all of our configuration variables, that we've got HDFS on the server, we can just simply download the RPM file off of the Elastic website and open it up and install it. So what do we need to do next? Well, I think everything Elastic made is configurable using YAML files. So what do we need to do? We need to custom configure our file beat. So we're going to take all of our configuration variables, and we're going to use the sed command in order to edit our YAML file. In order to do that, I've created a YAML template file, and we'll look into that in just a second. So we're going to run sed on that template file, and the output will be an actual YAML file. So what would a template file like that look like? Exactly like this. So this is an example taken from the template file, and if I can draw your attention to the EMR cluster ID, that type of configuration variable would be for the future. So just searching your logs by EMR cluster ID would make searching logs a lot more easy. And then if I can draw your attention to the bottom of the page, if you see the multi-line pattern, that's exactly the type of configuration variable that's for the legacy, right? We're going to custom tailor, install these file beats for that specific team. So we're going to install metric beat the exact same way. There's nothing interesting here, nothing new. And that's about it, right? At this point on, the architecture needs minimum development, minimum configuration, right? Because all of these parts, they natively work together. They're all by Elastic. But at the beginning of my talk, I said that we're going to have some obstacles, right? So what could an obstacle be? So our main obstacles were data engineers. And I think that data engineers suffer from a lot of things that regular software engineers suffer from. And that's with, all this good. Why do I need to configure all those Bootstrap actions? I can just SSH into my EC2 servers. I like doing that. But eventually, we've really shown them the benefit of just searching your logs with so much ease using Kibana, and everyone started using it. And so I have here for you a really nice Kibana chart, right? You can see that we had over 30,000 log lines with level warning, and then some 23 error lines. And this is really nice. This is really cool. I really like charts. I really like visualizing data. But this is the real star for me. So if you see the message line circled in red, this is what we were aiming for. We just wanted this. Everything else is a bonus. The fact that you see EMR cluster ID there, if you can, because it's really small, or the tags, or the Spark component responsible for this log line. Everything else is a bonus. Everything else is here just to make searching logs more easy and just understanding and getting insights from your logs a lot more better. So now let's talk about the future. What could we do else? What could we change? What can we add? So I think the first thing that we'd actually do is just replace Redis with Kafka. And if we're talking about Kafka against other services, so Kafka is a lot more robust, right? And as we were adding more and more applications to this architecture and our data volume started to grow, Redis was becoming sort of a bottleneck, right? So I think the first thing to do is actually just replace Redis with Kafka. And then the second thing would just be adding more EC2-based services to this architecture, right? Because as we've said, EMR is basically just a bunch of EC2 servers running together. So why not install beats on more EC2 services? So at Nielsen Israel, we had several of these, right? We had Kafka, had Schema Registry, we had Druid. So we could just do that and get our log visibility on an entirely different level. Any questions?
Okay, do we have a question in the room? Mm-hmm.
You can approach me anytime. You can send me a message on LinkedIn. I have a link to the slides. So if you have a question anytime in the future, feel free to approach me.
So thank you very much. We can applaud.
Thank you.